Hey there and welcome. Today, we're digging into the ground beneath our feet. We're on a mission to uncover this one single number, a powerful number that tells engineers a surprising amount about soil. So let's get into it and figure out the story behind something called specific gravity.
So let me ask you something. How can just one number, a number with no units, by the way, tell you for sure if an object is going to sink or float? I mean, it kind of sounds like magic, right? But it's actually pure science, and it is the key to understanding everything we're about to talk about. Well, the answer to that little puzzle is a concept called, you guessed it, specific gravity. And at its heart, it's actually really simple. It's basically a water test that gives us a score for almost any substance you can imagine. Okay, so here's the official definition, but don't worry, it's not complicated. Specific gravity is just the ratio of a substance's density compared to the density of a reference substance. And for most things we care about, that reference is just plain old water. We specifically use water at 4 degrees Celsius because, fun fact, that's when it's at its absolute densest. So really, all we're asking is this thing heavier or lighter than the exact same amount of water? And what's so cool is that this boils everything down to one magic number. 1. That's it. If a substance has a specific gravity less than 1, well, it's less dense than water and it's going to float. Think of a piece of wood. But if it's greater than 1, it's denser and it sinks, just like a rock. It is literally that straightforward. Okay, so we've got the basic sink or float rule down. Easy enough. But how does this simple idea turn into a super powerful tool for engineers? Well, that happens when we really zoom in and apply this concept to soil solids. I'm talking about the actual tiny mineral particles themselves. So when we talk about soil, the formal definition, which we use the letter G for, is the ratio of the unit weight of the solids to the unit weight of water. Now, what does that mean? It means we're isolating just the solid particles. We get rid of all the air and water that's in between them, and then we compare their weight to an equal volume of water. And here's where it gets really interesting. When we do this calculation, we find something amazing. For most common soils all around the world, the specific gravity G falls into this really, really narrow range between 2.65 and 2.80. Think about that. The big takeaway here is that soil particles are almost 3 times denser than water. And that's exactly why even a tiny little grain of sand sinks to the bottom so fast. Now, I know what you might be thinking. That range, 2.65 to 2.80, seems so small. How could that be useful? But actually, the opposite is true. The tiny little differences within that narrow band tell engineers a whole detailed story about what that soil is actually made of. So let's break down what those little variations actually mean. See, coarse-grained soils, like sand, are often full of quartz, and they tend to be on the lower end of that range, a lower G value. Then you have fine-grained soils, like clays. They can be made of minerals that are just naturally denser, so they have a higher G. Now, what about organic stuff? Well, organic matter is super light, so if you have a lot of it in your soil, it's going to pull that G value down. And on the flip side, if your soil has heavy elements, things like iron or mica, that's going to push the specific gravity way up. All right, so we've got the theory down, and we know what makes the number go up or down. But so what? Why does any of this actually matter in the real world? Why do engineers go through the trouble of measuring this one little value? Well, here's the payoff, and it's a big one. First off, knowing G lets engineers estimate the weight of soil, and that is absolutely critical when you're designing something like a building foundation. Second, it's like a secret code for what the soil is made of. A low G, that might be a clue that there's a lot of organic material in there. A really high G, that could point to some specific heavy minerals. All of this info is totally vital for classifying the soil and figuring out what you can and can't do with it in construction. So think about it. We started with a simple sink or float test, and from that, we get this one single number that unlocks the weight, the makeup, and even the identity of soil. Pretty cool, right? You now know its secret number. And it really makes you wonder, what else is hiding in the ground right beneath our feet?